Okay, hello everyone. We're going to get started with the presentations in just a minute. So if I could get everyone to find a seat, that would be great. Okay, so we're going to get started. We covered the note well yesterday, but just as a refresher for those of you who showed up today, everything in the hackathon and in the IETF in general falls under this note well. Covers like the presentations that you'll be doing here. So if you haven't familiarized yourself with it already, maybe before you present, see what you're signing up to. But it basically covers the IETF rules and procedures, and when you're sharing something here, that's an IETF contribution, the presentation that you're sharing. So the agenda, we came to this point, it's about 2 o'clock. We're going to get started with the presentations. And some people have been asking about the order, and the order is going to be based on the order in which they basically got put into the GitHub repo, because they're getting pulled from the GitHub repo, being pulled into MeetEcho, and then we're going to go through them in MeetEcho. So the first one is this one, because I uploaded it yesterday, and they're not appearing in alphabetical order. They're appearing, even though they might look that way in GitHub, it's basically based on when they came in. If you don't have your presentation in yet, we'll be looking for it to get uploaded to GitHub, and we will try to pull it in. So you'll probably be more toward the end. But so I can't tell you exactly when your presentation is going to be. If anyone has a real challenge with time, I know one person who does. We're going to try to fit that person in at a very specific time. Otherwise, we're going to basically go through them in order. If you happen to not be here when we get to yours, we'll come back again. So don't worry too much about that. But just to make it flow smoothly, we'll try to go through in order, and we can try to give you a heads up as to which one's next. You will be driving your presentation from up here, just like I am now. So basically, we'll share your slides, and then we'll give you control to drive it from this laptop. And any questions about that? Okay, I have some questions as to whether it's really going to work, but we'll figure it out as we go along. So far, so good. And I think that is it for that stuff. Oh yeah, with your presentation, just again, one more reminder, very quick hitting presentations. These are short, 4 minutes at the absolute most. If you can do it in less, that's fantastic, because we have like 20 or more of these to get through, and we need to get through them all with the changes over in speaker and that within 2 hours. So we'll have more time for more in-depth discussion later on, and maybe I'll just pull that up now too while I'm thinking about it. I think the next slide I have, this is a little slow. Oh, so this is the GitHub repo that your slides need to be in. And the longer time for presentations will be at Hack Demo Happy Hour tomorrow. We'll have a whole hour when you can sign up, you can be here, and you can talk to someone for an hour if you want about all that you did. So today, just try to get the main points across. Okay, and with that, we are going to go to the first project presentation. Let's see. So the first one I see is SDN-based MP TCP aware and MP quick aware transmission control model, and it keeps going, but hopefully that's enough. You know it's you. Anyone here to present that one? The next one after that is BMWG. But what about the SDN-based MP TCP and MP quick? No one here for that one? Okay, then we'll go to the BMWG container benchmarking. Was that the presenter I heard coming in? If you're remote, go ahead and take the audio and let us know you're here.
Okay.
Now, can you get my share? I wanted to share my desktop.
Okay, so I'm sorry, which person is this?
Okay,
which presentation?
Can you get my share desktop?
I can hear you, but I didn't. Are you the presenting the MP TCP and MP quick one?
Yeah. I am the SDN.
Okay.
Now, okay.
I'll advance the slides for you.
Okay. How to next PPT next page? How to get next page? Yeah. My project is SDN controller help host to select a path for traffic in multi-path. We know the default transmission control mode of MPTCP or MP Quick in SDN only select one same path every time, and not all the paths working. So we want to make all the paths working and improve the good put. So we want to make the controller extract MPCP or MP Quick packet to allocate suitable path by ALTO. I'm sorry. How to get a next? Yeah. So yeah. So our plan is we can see the picture. User one has two paths. One path is Wi-Fi. The other one is 5G. The other user two also has two paths Wi-Fi and 5G, and the SDN controller is the ALTO climate, and on the top is ALTO serve. So the right picture is the whole structure. Next page. Now, we can see from the picture, they are SDN serve and climate that is quick go or MP TCP. Our SDN controller is open daylight. Next page. We get the result. The result is the throughout of LP Quick or LP TCP using ALTO is higher than without ALTO in SDN, especially in per network. Why? We make all the paths working in SDN by ALTO. The default only one path, so the throughout is higher. After that, our test also include IPv6. In IPv6 environment, the throughout also higher. We can get the bottom pictures. Next page. What we learned how to use ALTO in SDN, and we get the difference between IPv6 and IPv4, and also we get the difference between SDN in MP Quick and MP TCP. Our project supports both MP TCP and MP Quick. Next page. So we get the conclusion. Our project about 3 times compared to the default transition control method. This is my email. Thank you very much.
Okay, well, thank you very much for your project and for the presentation. And if anyone has any questions, we do have a mic. You'll have to go to the mic that's in the middle of the room. If you're here in the room and wanted to ask questions, those who are remote, you can ask questions that way. Okay, thanks. I'm going to go to the next presentation. And it looks like that one is the BMWG container benchmarking.
Yeah, I'm in the present online.
Okay, I can advance the slides for you here.
Okay, so hello everyone. My name is I'm from the BMWG container infrastructure benchmarking. So this is our hackathon presentations in IETF114. Next slide, please. So the plan for all our hackathon events is provide the benchmarking result for the different considerations that we have mentioned in our graph. So it's all about benchmarking container network performance with the various network acceleration model and different configuration setting. Next slide, please. So what we have done so far is we have provide benchmarking result for kernel space, user space, magnet with SIOV, and a combined model with IOV and BVP. We also done some benchmarking result with different configuration with NUMA, huge space, and service chains. So based on the list on the right side, what's left is IETF acceleration model. So that's what we focused on this hackathon. Next slide, please. So we implement the IETF acceleration model by using the AF-XDP and OVS DPTK switch. So for the packet transmission between the NIC card and user space, we use AF-XDP with a new socket type available from Linux kernel greater than 4.18. And that AF-XDP allows attach eBPF program in the XDP hook as a kernel NIC driver to transmit packet to the user space and bypassing the kernel network stack to accelerate the packet transmission performance. And for the packet transmission between user space and container, we use the OVS DPTK with AF-HTTP supported version. So this one allows us to create AF-HTTP port to promote driver to point the packet from the AF-HTTP socket, and for transmit the packet from the vSwitch to the DPTK port, we use a vhost user. Next slide, please. So these are benchmarking testbed. So it's the same with our previous hackathon. So we use Intel NIC-card, Ubuntu 20.04 for the newest kernel, and we use Mantis CNI for provide multiple interface for the port. And for support of DPTK, we use a user space CNI. Next slide, please. So this is the configuration. Next slide, please. So about the results, so we observed that the OVS AF-HTTP have a pretty much similar result with OVS DPTK, but significantly lower behind SRIOV and BVP. So we think that the results lie at the vhost user and virtual PMD part between the container and the vSwitch, which is the same result. That's why OVS DPTK lower performance than BVP. So we think that if we can use AF-HTTP with the BVP, which is the one that supports a MEMIC interface, then the performance will be similar with BVP. Next slide, please. So in our upcoming hackathon, so we want to continue to explore the result of the benchmarking result of eBPF association model. So we consider 3 variations. The first one is AF-HTTP with the BPP. Then the cloud-native data plane, the CNDP, which is a new cloud-native is a space framework developed by Intel, just released in April, with Intel AF-HTTP and BEP. And the third one is a Cilium and eBPF-based CNI. So the difference between the 3 is at the packet transmission route between HTTP socket and containers, and how the traffic is handling in east-west direction. Next slide, please. So this is a quick summary about the difference between these 3 open source. So with the VP HTTP, it uses a MEMIC interface. With CNDP, it's use a unique Kubernetes plugin for the port to use a network device from the NIC-card, and the Cilium is using the Cilium library. Next slide, please. The difference between is east-west traffic. So with the vSwitch, then we have the vSwitch to route the traffic. With the CNDP, they develop their own user space network stack called CNET, and with the Cilium, the packet from in east-west traffic is provided using the eBPF program in the socket layer. Next slide, please. So this is our team members, our GitHub repository. Thank you for listening.
Okay, thank you very much. Do we have any questions? I don't see any in the room. Okay. Go to the next one. And Andrew, I see you're here. You're okay. Ooh. We may not have it ready then. Let me see if it's in here. You'd be probably the last one. Is it this? Oh, no, that's IP. No. Okay, yep, we're going to go ahead and we'll get it up there and we'll work you in once we can. We'll go to the next presentation. The Cozy? Oh, T-Cozy, sorry. I left out an important part there.
I don't have right access to the GitHub repo, so I emailed it to you.
Okay. Sorry, go ahead.
Yes, hi, I'm Lawrence Lundblade, and this is, we were working on T-Cozy. T-Cozy is an implementation of Cozy in C. T is for trusted Cozy, but we have a little T-kettle too. It's Cozy is, a format for CBOR-based format for encrypting and signing data objects. It's used by for a number of other things. So T-Cozy is it's a small embedded C library, commercial quality. So I guess about 3 months ago, there was only tcozy 1.0 that supported sign 1, which is only allows you to sign data with one signer, one public key. We're in the process of making tcozy 2.0, which lets you sign with multiple signers, lets you encrypt with a single encryptor, encrypt with multiple encryptors, and then it also supports MAC with a single key. And as you can kind of see, we made some progress on it here at the hackathon. We're not finished, but we kind of, made our way down the line a little bit on that. So that's all I have to say. It's in GitHub as tcozy. Thank you.
All right, thank you. Let's see. So next up is P4 implementation and emulation of MSG6. Is that a presenter in the room, or if you're remote, just go ahead and unmute yourself. Okay, I'll drop the slide.
Can you hear me?
Yes, we can.
Okay. Let's go. Good afternoon, ladies and gentlemen. It's my great pleasure to make a presentation here to share my project with you. This slide shows our hackathon plan. The plan consists of two parts: the P4 implementation of MSR6BE and the emulations based on Intel Tofino switches. Some related documents are listed below. Here is a schematic of the MSRBE that enables the source-indicated explicit replication of multicast and functionally implements beer to transport multicast traffic in a scalable manner. An MSR packet implicates the MSR header with the multicast bit string in it, and each bit in the bit string represents a receiver, as shown in the figure. So how does a multicast bit string works? We introduce the principle of RGB, which means replication through global bit string, as a new type of IPv6 destination options header. We're using the code point of non-MPLS beer header. RGB is used to identify the replication endpoint and realize the function of beer. We implicate the demos based on P4 and conduct some simulations based on hardware P4 switches. Here shows some realized functions. As the figures show, the RGB option is encapsulated and decapsulated according to the IPv6 destination address. Figure 3 shows the function of BIFT, and figure 4 indicates the forwarding and copying of bit strings. The emulation setup consists of two hosts, two P4 switches, and one IPv6 switch. Here we list and show our hardware equipments. Next, I will show our results. It can be seen from the results that MSR6BE is valid in explicit replication and forwarding, and it is compatible with IPv6 forwarding. In processing latency, replication and encapsulation of RGB option costs 318 and 315 nanoseconds, respectively. Well, we plan two main works in the next period. The one is the implement of MSR6PE with P4, and the other is deploying the simulation on CINI. Finally, if you have some interest or puzzles about the demo or any others, just connect us. So that's all. Thanks for listening, and hope to see you again.
Great. Well, thank you very much for your presentation. don't see any questions in the room. I don't hear any, so I'm going to go ahead and go to the next one, which looks like it is Alto FTS. Okay, great. Just work the slides using that.
So, hello, I'm Mehdi. I'm here on behalf of the Alto working group from Yale. And in this hackathon, we were focused on optimizing large-scale global data transfer for scientific networks. So, Alto working group has started to work with scientific data transfer stack from the early days of 2022. So in Hackathon 130, we were focused on integrating Alto with Rusio, which is a data transfer scientific data transfer application. But here in 114, we have decided to dig deeper into another level, which is FTS, and schedule the transports. And we have yielded these results after talking with like FTS, Rusio design teams, and also analyzing the behaviors of Rusio and FTS. Mainly to give the rationale, because FTS control architecture is like a robust. They use lightweight and also universally accessible control knobs to control the behavior of scientific data transfer. But they have like two main problems. The first one is efficiency of optimal usage of resources, and the second one is resource control. And that's mainly because they use some semi-gradient algorithm that is only taking into account the single local data transfer. So we have devised another stack, controller stack, which we call a transfer control network, transport control networking, and has three main components. The first one is tree Alto in the picture, and is a zero order optimal gradient algorithm that we have devised and implemented in this hackathon. And the latter one is a tree control that we were focused on this hackathon on that too. As is aggregating the aggregated information from Alto to enable global resource control. So these are the algorithm and a schema of the algorithm that is given in that slide, but given the time, I will not talk about them. So our goal in this hackathon were to implement a prototype of the tree Alto and tree control components that I previously talked about. These are the RFCs that are involved in this hackathon. Mainly the abstract network element and pass vector behaviors of Alto are considered in this project. So this is the first input of our system. One interesting behavior of this system is that the tree Alto part is enabled to integrate network information from multi-domains. Namely the network domain 1 and network domain 2 in this slide. More information are given in that slide that is available in the GitHub page, but they're basically the implementation of pass vector and cost matrix properties of Alto protocol. Given this, we were able to implement a universal zero order grade algorithm that is enabled to achieve optimality and resource control at the same time. So at the top of the page, you can see how we were configuring the bandwidth usage of each pipe in TCN, either with absolute bandwidth limits or relative bandwidth limits. And on the bottom part, you can see that our TCN optimizer can achieve optimality and also can limit the bandwidth usage of single connections. At the same time, which is unfortunately FTS optimizer itself is not capable of. So to wrap up, although we have implemented a prototype of TCN optimizer and integrated that with FTS in this hackathon. This is the very beginning of our collaboration with FTS Rusio and Scientific Data Transfer Group. And toward IETF 115, we want to integrate this system at large scale with our collaborators at San Diego Supercomputing Center and also ESNet. And finally, thank you all for your attention.
Okay. The next one is LP-WAN SCHC.
Good afternoon, everybody. So the LP1 working group has been working at IETF hackathons for about 5 years now. And for the most recent editions, we've been developing an open source implementation of the SHAKE header compression protocol. So LP1 is a working group interested in transporting IPv6 and IP-based protocol stacks over very constrained networks such as Sigfox, LoRaWAN, and those called low-power wide area networks, which have payloads of in the order of tens of bytes and data rates in the order of hundreds of bits per second. So we have two RFCs already out, 8724, 8824, and we are developing an open source implementation trying to help the implementers interested and come to grasp with the technology easily. And we also have continuing drafts which are mentioned here. So what we did is doing a few bug fixes in the code itself and also in the data model, the young data model that we are just completing the draft for, and integrating that model checking into the code. And we've also been working on validating the whole protocol, the whole suite, software suite on the macOS environment. And the last bullet point is we are writing an easy to read documentation, a user manual for the open source code, if you will. And we've been rewriting that very extensively during this weekend. So what are the outcomes? We have running code and we have a manual to help people use that code. And I think it's worth mentioning that the LoRa Alliance, which is an industrial alliance developing the LoRaWAN protocol, has committed to use our open source implementation as a reference implementation for device certification for their optional IPv6 or LoRaWAN technology, which draws on the RFCs that I've mentioned before. That's it for me. Thank you for your attention.
Yeah, it's been fun to watch the progress of this project with each hackathon. Okay. Next up, what do we have? I2NSF. This is another one we've had the benefit of seeing from one hackathon to the next and how it develops. So.
Thank you. Hello, everyone. This is Jeon Porjang from SKQ. Oh, okay, good. So this is the poster for I2NSF. So basically, this time, our I2NSF team demonstrated the feasibility of I2NSF data wrap. Especially this time, we completed implementation of security policy translator for intent-based networking. So this figure shows the architecture of security policy translator. So I2NSF user is a network security administrator. It gives high-level security policies such as some regulation of access in company or some enterprise. So the high-level policy you can see given to security policy policy translator. So first of all, it extract data from high-level policy XML file and then convert high-level data into low-level data using NSF. NSF stands for Network Security Function, and then it can generate the policy generator based on Pyang bind. So we can generate the low-level policy. So this table shows the mapping between high-level YANG, such as consumer-facing interface, data model attribute, map to NSF-facing is low-level security policy. So basically, we can matching to data model attribute using the Zhang-Xiaoxiao algorithm. Basically, we can measure the distance to passes for YANG tree, and that we can match each the attribute from YANG tree. So the detail part can be explained in our draft. Please refer to our draft. So basically, you can see this is the high-level security policy, such as during work time, such as the employee, cannot access SNS websites such as Instagram, YouTube during work time. So the basic idea is we want to make high-level data into low-level data. So basically, this left-hand side, there is high-level policy data, especially SNS employees will be converted into specific IP addresses, and then SNS website will be converted into specific URL such as Facebook, Instagram, something like that. In the middle, we have a network security function will provide the specific network security functions such as a firewall and web filter, something like that. So using security provisioning service using decision tree machine learning, we can figure out which NSF can be used for this security policy service. Next. And then using this procedure, we can translate the high-level security policy into low-level security policy XML file like this. So the previously, we have one XML file for the web access regulation. So it turns out that we can generate the two parts. Part one is for firewall, second one is web filter. So you can see employee converted into IP addresses, and also using web filter, the website such as Facebook, Instagram can be translated right there. So the interesting is we can, so we provide I2NSF, we high-level policy as a consumer-facing interface, low-level policy is NSF-facing interface. YANG module, so given to this security policy policy translator, so we can automatically map attribute without any invention of the administrator. And then XML file high-level policy will be translated into low-level policy automatically. So I think this is a very the interesting feature. So we demonstrated automatic translation between high-level YANG data model into low-level data model. Okay, so we can take advantage of our work for other area. So next step, we try to enhance our concept for intent-based networking, IBN. Maybe IBN can be take advantage for NMRG, okay, Network Management Research Group, so they can take advantage of our work. And also, our I2N step try to enhance the next step using a closed-loop security system for feedback control. And then also we implement our I2N system on top of lightweight cloud-native system such as Kubernetes. Okay. So that's it. And next one is IPWave. Can I present? Here.
All right, we're having a bit of a network difficulty here. Sorry, we seem to have dropped the MeTecho session. Okay. All right, I'm going to try leaving and coming back and see if that does it. No, it looks like we've crashed. I don't know if the network's working for anyone else, but it's not working up here anymore.
I can hear you.
It's not even coming back up. It can't get into MeTecho at all, but I think it's a network issue.
Yes, I think so.
We don't have a way to connect Ethernet here anyways.
So do you have a Ethernet port? No.
I think I have one in my bag. I'm just trying dropping the Wi-Fi and relogging in. So let's just see if that helps. What? Does the MeTecho robot still show up as being in the, oh wait, now it's working.
Okay. It looks like working.
It came back. We had to, anyways, let's see if this works. Better now.
Okay, now just wait for Sandro
going to promote you.
Oh, okay.
And I thought the movie robot.
It says super.
Super, okay.
Yep. Okay, so you have one other one.
A few waves.
It's that one. Where's IP wave?
I feel here you go. Yeah.
That's it?
Yeah.
Okay. Okay.
Thank you, Charles.
Yeah, sorry about that.
Okay. So, hello again. This is a project from SKQ. So, from now on, I will explain IP Wave Hackathon project. So, basically, this hackathon project, we want to demonstrate the feasibility of heterogeneous networking, such as IEEE Wave, Delta 11 OCB mode, and 3GPP LT mode 4. So it is called the CVTX. So you can see in the middle, beacons can communicate with each other using a wave or a CVTX protocol. So IP wave, I have individual draft. It's called the context-aware navigation protocol (CMP). So basically, CMP provides two messages. One is a corporation context message for normal driving condition, and certain accident happen or some driving hazard in front of a vehicle. So emergency context message ECM can be generated and disseminated all vehicles to protect the vehicles, okay, avoid accident. So we tested the coexist distance of IEEE 11 OCB. It is called the WAVE, the wireless access in vehicular environment, and also the 3GPP V2X protocol, such as 3GPP LT mode 4. So mode 4 is for a V2X protocol mode. So basically, we demonstrated our hackathon project using OMNet++ for networking simulator, and Sumo is the vehicle mobility simulator. We combined using base architecture. So you can see the vehicles moving in highway scenario. So we implemented on top of the base for Delta 11 OCB. We implemented the logical link layer, combine the wave, Delta 11 OCB and CVTX. So the challenge is how to integrate. So let me show you the protocol stack here. So left-hand side is the 3GPP protocol stack. So you can see 5G VTX or the LT Mode 4 protocol stack. And right-hand side, we have a wave protocol stack. So on top of them, so we have a logical link layer. So we can forward some MAC layer packet to TCP/IP layer or non-IP based layer, such as WSMP, Wave Source Message Protocol Stack. So we implemented this protocol convergence for this hackathon project. So we showed the feasibility. So I think the Wave and the 5G V2X or LT Mode 4 can be combined together, so we can provide the vehicle driving safety. So we have open source project, so you can access GitHub using this link. You can download. So this is a collaboration work with Sungseo University and the Gyeongsang University. So my students are Bienami, Junhee, and Hyuna. Thank you for listening.
Thank you, and sorry for those technical difficulties, but hopefully smooth sailing now. Okay, I'm gonna look and see if we got Andrew's. Andrew, are you still here? Okay, come on up.
Okay, thank you. Our team was focused on extension header testing, and in particular for the DOH, which was containing PDM information. Little brief information about PDM. It's got some great information about network management information and session information for IPv6 sessions. Really valuable to network operators, we think. But the catch is we use extension headers to transmit that information. And there's been some concern and some studies that show that a lot of extension headers are getting dropped in the internet. So we've been doing a lot of testing and focused on, is that true and where and when and why? What we've done is open this up and use actual data, real sessions, real information in PDM, and do testing all around the world. And we've used applications such as FTP, sites such as Toronto to Mumbai, and we put this through the test and done a lot of tracing. And here's some of the tracing results. You can see where the blue arrow is, that the PDM data is in there, and it did make the transition. In some cases, we had multiple extension headers. In this case, it's fragmentation and PDM. And the bottom line is all this is working. And now I'm going to turn it over to subsequent presenters to give you the details on where, when, and why, and how. Anthony?
Thanks all. Yeah, so we obviously tested FTP. We're testing with VMs from a plain old VM provider, not your average tier one like your AWS, OVH, Rackspace, because we wanted to avoid things like overlay networks, which could, hide this because it's one network. And we also did testing from this IETF network this morning just to prove, it's not just VM networks, it's normal networks as well. And we also, in the tracing that was going over multiple providers, we had transit networks in play. And this is all running on VMs with BSD11. We got a kernel patch that does all that PDM injections. And we saw it in all the scenarios, including in those fragmentation headers. And if you look at the VM to the VM, top left is the request, the bottom right is the response. And if we looked at the IETF network, we even got it here. If you look closely enough, you'll see that the response IP is the same subnet as here today. And look, it gets over the internet, but we're only scratching the surface. As we started digging into this, and Andrew will mention a bit more, when we tried to break the RFCs, it started suggesting we've got some security issues that we need to investigate. So there's a lot more work to be done. Thomas?
And this is to wrap up quick, because the point is that in order to implement security, you don't have to have, you want to minimize unexpected behavior. So we are not saying that it is right to drop the extension header. We don't say that it's right to let them pass through unexpectedly, but we must have some work to do actually in order to define where the problem is and what are the best course of action. Because as it is, the problem is it involves everybody. Us, because, well, we are not clear, the implementation, the user, and a lot of security issues can arise from that. What we are proposing actually to work on a BCP, basically outlining what are the assumptions of extension headers, and not all of them, but what have to be outlined in RFCs, how they should be treated, how we should actually test them, or what we expect from them actually, because they can be extremely valuable for not only what we was working on, the performance metrics, but for everything. And but we must make use of them in the right way. So basically that. We already have some possible mitigations, but we don't want to talk about the mitigations before analyzing the problem. It will be too early. But just saying we can have roughly either let them pass without considering them, encrypting, authenticating, because sometimes it's a matter of being sure that the actual extension header are right. And basically, Andrew, the floor to you.
Okay, I'm gonna skip slides and just give you a very quick overview of what I did to do some testing on this. I wrote some code here. So we decided that the destination option stuff, as they said, we could get that to work pretty much anywhere. But what about hop-by-hop extension headers? This was really interesting. So what I did was I decided to violate 8200 entirely, take our firewall code base and modify it to say that if it's a v6 packet, the v6 packet is an MTU of 1200 or less, because I didn't want to run into fragmentation issues. I would slap a random extension header on there, be it a hop-by-hop or a destination option, and send it out across the internet and see what broke and what didn't. Destination options, no problem. Got everywhere. This network, and this is from my house in Kenya, I've rerouted that over about 6 different transit providers, absolutely no issues. The hop-by-hop was far more interesting. What I found with the hop-by-hop is not that it was being filtered on the internet in general, but that it was actually the routers behind which my test boxes were sitting that were dropping it without even being told to. Now, the question and the problem that arises with that is we don't know what the state of filtering on the internet is, because I could have a bug in the router code that I've got, or the vendors could have gone, well, we can't handle this on the slow path, so as a result, we're going to throw away these packets for now, but either situation is subject to change. It's not the behavior that was expected in the RFCs. That does create a really big security issue, because you've got operators out there who are operating on an assumption that stuff is being filtered. We can't say that for sure, and in every test that we did, we found that it's more common that it's actually being dropped without any filters being specified, either because of bugs in vendor code or because they've deliberately chosen to drop it because of not being able to handle the slow path. We're not sure which. And so, yeah, that was just a little bit of code that we wrote, and I'm quite happy to talk to anybody about that. I'm around, and yeah, it was an interesting test, but what it does show is don't rely on the fact that your HBH is being filtered. Do rely on the fact that your destination option stuff probably isn't being filtered. Plan your security accordingly. Thanks, guys.
I know we don't have any time for questions, but come and see us in the back left. We need all the help we can get. Thank you.
So I have just a sort of a little announcement. The knock was in here. We were looking at why the Wi-Fi is so messed up. I guess somebody has like a Google Nest hotspot or something. Just letting you know that maybe the power is too high on it, or whatever. But it's what's screwing up the Wi-Fi in here.
Okay, thanks for that detective work. And if you think you might be responsible for that, maybe unplug something or reboot it, take it off. Okay, so let me go back up here. Where are we? We are Mask Connect IP. Okay, all yours. Yep.
So, Magnus Westerlund. So representing the mask table over there, we try to implement Connect IP. So we have already some running implementations of UDP tunneling over quick, but we're now focused on the IP parts. And the goal was try to reach interoperability. we do, I think, both implemented the protocol mechanisms, etc., but we didn't reach interop because we all struggled with actually getting the packets in and out of the tunnels. I think that was the primary problems here. And I think to launch a little bit more preparation, at least from my perspective, from me and Marcus, if we looked into this, maybe prepared some of our cloud environment, maybe so we could have multiple interfaces in the cloud and things like that, that our default policies wouldn't allow. So there's some preparation stuff that we could have been done better. But I also think that's really the lessons here about issues around more the environment and the actual implementation. So, and the people from Ericsson and Google is on the list here, and the draft GitHub if you want to contribute to the draft. So, thank you.
Great, thank you for that. And next up, VCon. Okay. All yours.
Hi, I'm Dan Petrie. Before I start, I'm going to take a few gratuitous minutes to explain what a VCon is. I apologize, we didn't get our draft done in time for this IETF, but it'll be there for London. So you may ask, well, what's a VCon? VCon is a standard container for conversations. All right, and the next question is, what's a conversation? Well, a conversation could be a SMS chat exchange, it could be an email thread, it could be a two-way call on the PSTN, could be a multi-party call with audio and video on Zoom or Google Meet or whatever. And so, it may be a combination of those things. You may start in one media and move on to another. And so, what we're proposing here is a standard container for conversational data. We have things like, call detail records. We have, standard containers for the media for a conversation, but we don't have a container for everything. And so we think of a VCon as having four parts: the metadata, who, what, where, when, things that you might have in a call detail record, the dialogue or the actual media that was exchanged in the conversation, text, audio, video, and you may have real-time or post-conversational analysis, a transcript, a translation, sentiment analysis, and you may have some documents that were exchanged as part of the conversation as well. Maybe a presentation that was put on in your Google Meet conversation, or an NDA that was signed in the context of that conversation, whatever. So what we'd like to see is a standard container for all of these things, which are all components of your conversation. And so then you may ask, well, why do I want to do that? Well, it really makes integration of services much easier. I can provide a much easier way to provide translation, transcription services, sentiment analysis services. A VCon becomes a nice tool for analysis of conversations. If I'm a call center and I want to analyze, how my agents are doing, or if maybe one of the agents has got a problematic headset, and you might be able to detect that, that the customers can't hear them. A VCon becomes an asset for a call center that is doing cold call dialing. Maybe they create a VCon and sell that VCon to a salesperson or a sales service as a hot lead, right? It's robot food, right? For machine learning and analysis. So having a standard container really enables a lot of services and capabilities. And so this is what kind of we're looking to achieve with the VCon. So we already have a draft that's in progress. We didn't get it done in time. It's 70, 80% there. We're working on that in parallel. We have an open source implementation. We wanted to implement encryption and decryption because there's privacy concerns over the contents of a vcon. And we had the idea to create a conserver, a conversation server, which is a kind of a RESTful API for storing vcons or whatever. So those were our ideas for the hackathon here. What we actually got done, we used Jose encryption as a means for encrypting the vcon. Vcon is a JSON container. We had the birth of our conserver, and along the way we were using some of these tools. We with the open source, we were able to generate some encryption examples for the ID that we're still working on. The ID is online. The code is online. And what did we learn? Well, we found some bugs. Going through examples, helps. And we found some bugs in our code. No issues with the draft yet because it's not done. Other than that, we're filling in more of that. After going through in applying Jose for both signing and encryption, we kind of feel like we want to reduce the algorithms that need to be supported for vcon to just kind of reduce the coding requirements. We came up with no work group issues. We don't have a work group yet, so that's stuff in progress. We had two remote people working on the project, and as I said, we're on GitHub, and please contact me if you're interested, want to know more, or want to participate. Thanks.
All right. Yeah, and when you do submit that draft, make sure you also add the additional information of related implementations. So we have a link to that. I want to see more of that. Dnsec Bootstrapping.
Yep. Hi, I'm Peter from Dnsec, and at the DNS table, we've been working on Dnsec bootstrapping stuff. So I'll tell you quickly what it's about. So we were working on implementations of the draft that is listed here. And the idea is, or the problem that the draft tackles is if you have DNSSEC for a DNS zone, you can sign it, but then you also need to put the trust anchor in the parent zone. And the protocol proposes how to do that automatically. And there is an implementation site for the parent and one for the zone operator itself, for the child zone. And we were working on automation for the second part. So the protocol requires that you publish a copy of the zone's CDS and CDNS key records at a subdomain of the name server hostname itself. So for example, if the zone is example.co.uk and the name server is ns1.desec.io, you would have to provision this record that's listed here as an example. It has an _ds boot prefix, and then there is an intermediate label _signal, and also the child zone name and the name server hostname are encoded in this record owner name. And then on the right-hand side, the value of the record is the same one as in the child zone. And you can use that to do validation as long as you don't have a chain of trust to the target zone yet, because you can have one to the name server hostname if that already does have DNSSEC. But there's no automation so far, so the hackathon plan was to automatically generate these records, and we were thinking about how to do this. One can either write scripts and run cron jobs periodically, for example, or synthesize these records dynamically in the authoritative name server software, which would require touching code from, let's say, power DNS or not DNS or bind. And then whenever that service is queried for such a record, it would go and look at the target zone and then, get it and sign it with the corresponding keys and all that. So what got done. So we first agreed on conceptual questions, especially what kind of configuration would be needed. And we agreed that it would be good to expose only minimal configuration to the administrator of the DNS server. In particular, we agreed that if a zone, like for example here, the underscore signal.ns1, .name server zone, is tagged in the name server as a bootstrapping signaling zone, then the agreement was that this enables synthesis of these records for all zones managed on this name server. So we don't have any particular sub-configuration. We figured that's easiest and has no harm. Then we wrote code. We got some code running. That's really cool, I think. They're a good result for the hackathon. In fact, my expectations have been over-satisfied. We got some code written for a cron job that's deployed at saltant.net. And it consumes a catalog zone, which is another new DNS feature. And from that, it extracts a list of zones that the name server is authoritative for, fetches the bootstrapping records, and creates the bootstrapping zone. So there is a link here to the GitLab repo that has this code. And also at Dnsec, which is a managed DNSSec hosting platform, we were working on synthesizing these records in PowerDNS. And it's also gone in production today, I think around lunchtime when the deployment was done. There's the pull request here also in GitHub. We also worked on integrating this natively into not DNS, but it's going to take a little longer until that's finished, so that's in the works. The techniques used were for the cron jobs and Python script, for the PowerDNS implementation, Lua records, which allow you to run code while processing a query. And for not DNS, it was a C module for the server software. We learned that it's pretty straightforward to implement this. I was more skeptical in the beginning. We learned some things about Lua and learned that it's good to have people at the table who know how to use Lua. We had an unexpected insight in a protocol detail, which is, I guess I'll skip over it here. I guess most people aren't so familiar with it, but for us it was very insightful. We can discuss later here if you want. And overall, the protocol seems pretty workable in practice. I have a short video, about 22 seconds. I will allow myself to, is it possible to start it here? Okay. So I will try full screen. No. Play. Okay, I will first say what you're seeing before I start playing, okay?
Will it let you do that? No? Maybe not. Actually, there's probably a way. I don't know how to.
Okay, it's not very interesting. So there's two terminals. I mean, I can describe it, and it's probably more interesting when you see a human describing things and making jokes and mistakes. Anyway, there's a terminal at the top which runs an API command at the DSEC, a DNS operator, which creates a zone, and that automatically also creates DNSSec key pair. At the bottom, we're querying these records that we're looking for to provision automatically. In the beginning, there is a DNSSec proof of non-existence because it doesn't exist yet. Then the video would start. You would see how the domain is created when we hit this command in the command line. You get the output, you see confirmation, it's confirmed, then you wait only about 15 seconds until on the secondary server, you will see that these records have been provisioned automatically thanks to the Lua script that is running on the server now. So this is roughly what the video has, and you can check it out if you go to the IETF114 hackathon, look at the source code of this HTML file, and dig out the URL. So that's the wrap up. Team members were John, who's an IETF hackathon first timer. He wrote the cron job script and deployed it on his servers. Also, Niels is the first timer at the hackathon at least, and he worked with Jerry on the PowerDNS Lua scripting synthesis thing, and I've been working on the not DNS. Thank you.
Okay, great. Thank you. And what do we have next? We have, so this one just says IETF hackathon. Has the date on it, July 24th. Sorry, what would you say about? I'm just going to go to the one tax API while I figure out what that other one is. You come up for the one tax? CO2, I don't, is it this one? I don't see CO2.
Hi.
Oh, yeah, that's this one.
That's this one? Oh, okay.
Hi, so I'm just going to be very short. We implemented a few functionalities. One of them is we introduced the way UK is computing CO2 for air flights according to distance and destinations. And we also Dockerized the service. It's a student remotely did that. And so everything is on the web page. You can check everything. Thank you.
Yeah, and all these are on the GitHub in addition to being in the data tracker now, so you'll be able to find them. Okay, one tax API. Do I have a presenter here for that or online?
Can you hear me?
Yes, I can now. Just let me know. I can drive the slide. Actually, who is this presenting?
So this is Benson Moite.
Ben.
I guess I put my name at the end rather than at the beginning. Sorry.
Okay, I'll just drive the slides for you.
Great, thank you. So next slide, please.
Okay.
So aim was to look at a slightly new programming language, HARE, and this is being implemented as a systems programming language that's supposed to be relatively stable once it's finished. And there's efforts to add encryption to it, and many of these encryption protocols are described in RFCs. So next slide. So basically looked at what issues were there. Two things that look like should be added are Ristretto, which is currently in the last call, and AS/GCM SIV, which has been published but not been implemented in HARE. And guess what got done is adding conformance tests for ED25519. So next slide. So there's a guest paper from about 2 years ago where they suggested some further tests that are needed. And they examined a number of different implementations of ED25519. And they found that for these corner cases, the library implementations basically don't agree. They made some other suggestions that would improve it as well. But at this point, I just looked at the tests, and the line at the top is the new one looking at the HARE implementation. So I guess it also doesn't seem to agree, even though it was based on Tweet and ACL. So next slide. So what I kind of learned, so there's some curves that have been partly implemented in HARE. They need more testing and validation. The tests came from this paper by Chalkias, Garillo, and Nikolaenko, who also suggest improvements that would allow for applications in contract signing, electronic voting, and transactions. And their test vectors should, I guess my suggestion is that probably their test vectors should be added to RFC or made a supplement, just so that implementations that do comply with the RFC can be said to comply in these corner cases. Next slide. So thank you for your attention. There's a very good JavaScript implementation, which I did not have much time to look at, but that also has Ristretto, which might be a good starting point for the Rust version of that. Thank you.
Okay, thank you, Benson. Do you have any questions? All right. The next one. Code sprint presentation.
So as always, the plan with the code sprint is to improve the tools that are used to make the IETF work. In particular, the data tracker and XML to RFC. We've been doing this since IETF 70. So if you find that there's some little thing that annoys you about how one of these tools works, fix it. And so we actually got a fair amount of things done. We got 24 data tracker pull requests, closing 13 tickets, 7 commits against the XML to RFC, fixing 6 tickets. Here's the list of the 18 people who participated, some local, long table on the side, some remote. There's the links where you can find the code. If you're interested, can, of course, continue to work at any time. And there's a mail list for tools discussions if you want to discuss anything, the way anything works and why. So that's really all there was to it. Thanks.
Great, thank you. That's exciting, all the functionality that's and the stuff that's been done with the data tracker lately. Including the related implementations. I'll mention that about 10 times. Huh. Okay, IP wave, we did that one. Drip interop.
Hi, I am Tim Mesker. This is Adam Whitaker, and we are here on behalf of the Drone Remote ID Protocol Working Group.
We're going to do a lot of swapping here. So the DRIP Working Group's main objective is to bring safety and security into unmanned aircraft, specifically for remote identification, but also kind of tie a little bit into UTM, which is UAS traffic management.
The DRIP protocol accomplishes this by generating cryptographically verifiable remote IDs, registering them into the DNS, and enabling correlation of these remote IDs with operator and aircraft data in a privacy-preserving manner.
So for the hackathon, we have the challenge of a lot of UAS is closed source, and we have a closed source broadcaster implementation and a structure of a DNS and registry system. So we wanted to bring the two of them together during the hackathon. And for the 2 days, we accomplished actually doing a live registration of a session ID through a puck, public information lookups using that session ID using DNS, authenticated lookups of non-public information using that session ID. And then we found a lot of shortcomings in our proposal in the RFCs. And we have plans to go forward that we're going to be proposing to the working group tomorrow, Monday, second session on how to improve.
And if this video works, we were able to film a live demo. It does not look like it's going to work. All right. So what the demo would have demonstrated is we have a drone simulation running in Microsoft AirSim. We have that plugged into a software in the loop version of PX4, and we have that plugged into Q ground control. And we have those Mavlink packets from Q ground control routing to a puck implementation, which allows for backwards compatibility with existing drone hardware. That puck is broadcasting using the DRIP protocol. It is being picked up by the two phones that you see. One of the phones is unauthenticated and is able to obtain relevant public session information. The other phone is authenticated. That enables it to obtain serial number information associated with that session. Thank you.
And we'll be at the Hack Demo Happy Hour, where I'll be doing this live for the whole hour. I'll keep generating session IDs and registering them over and over and over again. And hopefully it doesn't break. Thank you.
All right, and a good reminder to other people too to sign up for Hack Demo Happy Hour. All right, L4S.
All right, good afternoon, everyone. So I'm Greg White with Cable Labs and joined by a number of the other champions for this project. Here, Vidi Gulal from Apple will be presenting part of this as well. This project is taking up the front 5 tables in the corner here, as well as we have racks of equipment hidden in the back there. And to some degree, this is a hackathon project. There is some hacking going on, but it's also the first interoperability event for L4S that is taking place in the world. L4S, if you're not familiar, is the low latency, low loss, scalable throughput architecture for congestion control and congestion signaling in the internet. It's defined by 3 drafts, which just finished IETF last fall, so hopefully we'll be seeing those published as RFCs fairly soon, as well as 1 draft that describes how the congestion feedback works for TCP implementations, and that one is still in progress. There are 3 components to the L4S architecture and to make it work. You have got the congestion control at the sender, you've got congestion marking in the bottleneck link along the path, and then you've got marking feedback that's coming from the receiver back to the sender. And we've got implementations of all of those here today. And actually, our plan is not to finish today. We're actually planning to going all the way through the end of the day on Tuesday. There's a fair amount of setup involved in getting all this networking gear here. We actually started yesterday afternoon or Friday afternoon getting things set up. And yesterday, most of that was really debugging the network, getting everything going. We've got some initial results to share with you guys today. Tomorrow at the TSV working group session, we'll have an update with additional things that we found. And then again, continuing through Tuesday with additional testing. In terms of the implementations that we have here, so on the congestion control side, on the sender side, we've got 5 different implementations from different companies and organizations. On the receiver side, the marking feedback piece, again, we have 5 different implementations there. These are quick as well as TCP, as well as some proprietary UDP implementations. On the bottleneck link piece, we have 7 different implementations that we're testing. 4 of them are what we call low latency Docsis, which is a version of the Docsis protocol, which supports the L4S functionality. For that, we have 2 cable modem implementations and 2 CMTS implementations. We also have a couple of Wi-Fi access points that implement L4S, and then a network emulator from Nokia that can emulate a 5G RAN. 6 of those 7 bottlenecks implement the dual queue coupled AQM draft that I had on the earlier slide. One of them implements an L4S aware FQ scheduler and AQM. In terms of what we've tested so far, in terms of interoperability, this is a list, a possibly complete, maybe not complete set of things that have been tested so far, but different congestion controllers, different bottleneck links, different receivers, trying to work our way through the full list. And in terms of results, I'll hand over to Vidi to talk about these.
Thank you, Greg. So we did some testing using the Docsis implementation from CASA as well as CommScope, and we did some testing for upstream as well as downstream traffic. This one shows the classic results for the classic traffic for upstream. If I remember correctly, this is done with CASA, and it shows basically what we see with the classic congestion control, which is cubic. And you can see the highlighted box where we show the PDV stats, where P99 is 30 millisecond and P99.9 is 125 milliseconds. So there's a lot of delay variation, which means there's a lot of jitter as well for the classic. And if you look at the L4S upstream, this is again with CASA, but this uses our L4S congestion controller and the low latency queue instead of the classic queue. And the PDV stats, again, if you look at P99, it's 9 millisecond and P99.9 is 10.3 milliseconds. So there's a huge improvement, or I should say a huge reduction in the latency for L4S as compared to classic. Please note that for the Docsis implementation, there's this request grant delay, which is basically the minimum delay that some packets will always see. So it's not that the P99 being 9 millisecond, not all of it is queuing delay. Some of it is the base delay or the request grant delay. Moving on to the downstream testing. This one I think we did with CommScope. We did with CASA as well, but the result is with CommScope. And if you look at the classic, again, the P99 is 55 and 99.9 is 96 for classic traffic. There's a huge delay variation for classic. And if you look at L4S, the variation is much smaller. It's under 2 millisecond for P99. So these are our results for L4S downstream and upstream traffic, comparing the classic queue. Just want to thank everyone helping with the testing. A lot of people sitting on those 5 tables that Greg mentioned have helped with testing and setting up the network, doing metrics and measurements. These are the participating organizations, and these are all the members who have been working really hard to make this possible during the IETF hackathon. Thank you.
Okay, great, thank you. And a good example of how projects can continue, and you continue to work here over the week as part of the Code Lounge, which this will turn into. And so we did this one, so I think we are done. Is there anyone with a presentation that we skipped over? Anyone online who was expecting to present and we didn't get to? Okay, great. So thanks to everyone for keeping your presentations not only super informative, but also relatively short, so that we were able to get through them all. Mentioned a few times, we have a couple more things after this. We have the Hack Demo Happy Hour. A few of you have already signed up. If you look on the wiki, the hackathon wiki, you'll see right underneath the agenda, it mentions the Hack Demo Happy Hour, and there's a link to, reserve space for your table. Please do that as soon as possible if you plan on joining us there. And the deadline to sign up is by noon because we need time to set up the room and make sure we have enough space, enough tables, and that type of stuff. Kind of typical happy hour, there'll be a little bit of things to nibble on, and then there'll be a cash bar there if you're interested in getting drinks. And I think there will be some free sodas and water and that type of thing too. And that'll be in this same room. Any questions about that? Okay. And then I also mentioned the code lounge. So Hack Demo Happy Hour is just for that 1 hour, but this area will essentially turn into the lounge for the IETF meeting. And there's a portion of it that will be kind of signed off as being for the code lounge. It'll probably be up here so that it'll be close to the equipment, I would imagine. But in any case, you can also, there's a sign up sheet there, and that's just for your own reference and to let other people know as to when you plan to be here. So I saw the L4S, they already signed up at the times they plan to be here, and that's great. Others are free to be here. There can be more than one team here at any one time. That's actually a good thing because then you have multiple teams that can work together. So feel free to take advantage of that too. And just one more shout out to our sponsor, CNNIC. There's various sponsorship levels for the hackathon, and so we're always looking for and hoping to get more sponsors. So if you can consider doing that, that would be great. And thanks to CNNIC for sponsoring us again. And then thanks to all of you for participating in the hackathon, for working with us through some of the glitches too. This is every time I think there's something new that we try. This time the integration of the slides with Meetecho had some really nice benefits to it. Many of you may have interacted with Barry. He's in the back there, kind of silently making sure that, thank you, Barry, that he's my co-chair with the hackathon and making sure that, everyone got added to the GitHub organization, that your slides got uploaded there, and that they then got into Meetecho, and then the Meetecho team was, of course, great, and the NOC team working with us on the network. So realize that all this happens the weekend before the IETF meetings really starting. So a lot of stuff, not only your projects, but really the whole IETF network, everything's getting set up. And the fact that we're able to pull this off and have things be as stable and work as well as they are is really phenomenal, and a tribute to the NOC team and Meetecho and the whole AMS staff. So really fantastic. And then we're always looking for people to help us make the hackathon better. So you can share your ideas with me and Barry. If you have more than just ideas, but you actually want to help us join our team so that we can work on the hackathon together, and maybe you can be up here doing the presentations, running the presentations next time. That'd be great too. So talk to me, talk to Barry about that. We'd love to hear from you, and we'd love your help. And with that, we are done. The next hackathon will be in London, and we'll try to make sure we have plenty of space and a good setup for all you there. So start planning now. I hope it's possible for you to join us in person again. And in any case, save the date. It'll be the weekend at the start of the IETF meeting. So mark that in your calendars and start making your plans now. Well, thank you all. Please have a great and safe IETF week. By the way, there is a mask up here that that someone may have left. So if you're missing a mask, you can come up here and grab it.